Hello, everyone. My name is James Palkey. I apologize for a little bit of the disturbances before, and the disturbances from my mic. But I'll be teaching you guys trigonometry through this podcast series, and I hope it goes fairly well. Um, this is the beginning episode, so we'll cover the fundamentals. Okay. That being said, we're first going to touch on right triangles. Um, Obviously, the name trigonometry really means we're studying triangles, but we're actually going to focus on right triangles and sort of we need a refresher. But the angles of a triangle, all the interior angles of a triangle always add up to 180. Okay, regardless of the type of triangle. So you have equilateral, isosceles, scalene, and right triangles. Okay, but all their angles always add up to 180 degrees, right? For an equilateral triangle, it's 60, 60, 60. For a right triangle, it's 90 and two other sets of degrees, you know? But yeah, they always add up to 180, regardless. That's just a fundamental fact um, about triangles. Now, as I mentioned, a right triangle is one which only has one 90-degree angle, um, and you can't have more than one 90-degree angle in a triangle. Now you can have one angle that is greater than 90 degrees, but that means your other angles are going to be acute angles. Like you could have a 91-degree angle, but you can't have another 90-degree angle or 91-degree angle. Because two 90-degree angles make straight edge, and well, as we'll find out, you can only have 180. The side opposite of the 90-degree angle is referred to as the hypotenuse, guys. The hypotenuse is also the longest side of a triangle. Um, so back in your geometry classes, you learned of Pythagoras and Pythagorean theorem. Well, the hypotenuse in that case is c, a squared. So one side, the square of that length times plus the square of the other length that isn't the hypotenuse gives you c squared. One side squared plus another side squared gives you c squared, hypotenuse squared. And you can use the square root to find what the length of a hypotenuse is. Um, we always use degree when we're referring to triangles and their measure. So yeah, we always use degree. Um, but later on in trigonometry, we'll be using radians, things like that. So just get used to using degrees for now. Degrees. So degrees are written as the little circle, small little circle after you write the number. And it's a fraction of a rotation, right? We all know, oh, he did a 360. Oh, he did a 720. If any of you guys are skateboarders, so, um, but we don't say, oh, he did a 2 pi r, or he did a 2 pi on that skateboard. We always use 360 degrees, okay? 360 degrees is typical, and that's what we use. So just keep using 360 degrees. And we're all so familiar with 360 degrees. 1 degree is 1/360th of a rotation. That's why we just say 1 degree. So there are 360 degrees in a circle, and there are 90 degrees in a right angle. So 90 is 1/4 of the circle. Um, and obviously the pairs of 90 are these quadrantal angles, which are 90, 180, and 270 and 360 degrees. Those are the angles which their measure is exactly on the x, y, or x axes. Okay? You can confirm a right triangle, 90-degree angle with a little box. We see that a lot in triangles. Um, they'll just, or on your test or whatever. There will be tests, so I hope you guys taking notes. But I'll just put little box just to confirm, or I'll write 90 degrees, but mostly just put a little box and that signifies the right triangle, okay? Or right angle, obviously for right triangle. Markings of undefined angles. So obviously in this class, in this course, you'll learn a lot about determining angles. Um, and so what we use for finding the unknown angle is we use the Greek symbol theta. If you don't know what theta looks like, it's essentially just a zero, but with a line running across the middle of it. And it's just Greek letter. You can look it up. Theta, theta. Um, yeah. Um, a little side note to that. One of the reasons we use 360 degrees is because 360 is very close to the number of days in the year, 365, and this was dated back to the Babylonians. And simply because 360 is also very easily divisible, right? Think about you can divide it by 2, by 3, by 6, by 4, by 12, all these things. But 365, right? 300, 365 divided by 4, or divided, yeah, 365 divided by 4, that's not going to give you a whole number. That's 91.2. Um, so that's why we use 360. Um, Now, if we move on, the next thing is, oh, well, what would some of the fractions be like? I just want you guys, as you're thinking about it, fractions of 90 degrees is, well, that's 1/4. Pi is 1/2. That's 1/2 of a circle. You really, if there's one thing you take away, just try and remember 180 degrees is 1/2. That'll be useful to you. Now angles of theta. So if you're unsure, you can just sort of classify them. So anywhere between 0 and 90 degrees, that'll be an acute angle, okay? And we all know what acute angles look like, obviously. Um, they're less than 90 degrees. So greater than 0 degrees and less than 90 is an acute angle. Right angle is where theta, the degree, is actually equal to 90 degrees, okay? An obtuse angle is where 90 degrees is less than, theta is greater than 90 degrees, but also less than 180 degrees. Okay, now straight angle. This is where we come into the specialty of 180 degrees, right? Straight angle is 180 degrees. That's the only thing. Do not call 360 degrees a straight angle because that's one whole rotation. That is a straight line flipped onto itself. Um, there's only one straight angle, and that is 180 degrees. Now, what we call a reflex angle is anything that goes beyond 180, but before 360. So that whole, you're all familiar with Cartesian coordinate systems, the coordinate plane. Any angle that exceed the first two quadrant. So anything in the third or the fourth quadrant that is not 360 degrees is called a reflex angle. We're getting pretty close, guys, to the end. I just want to say thank you guys for tuning in. There will be more lecture. Obviously, this is just the beginning, sort of understanding and studying the angles, the right triangles. I hope this lecture was helpful to you guys. That's about what I have to say for the beginning and the fundamentals of trigonometry. Obviously, we are need to combine all these things, angles, sides, measure, and triangles later and later on. But this is just a refresher. So if you're really just stuck on any particular topic after you've listened to this series for a while, come back, watch this first episode. This has been episode 1 of trigonometry. And thank you. Please check out our sponsor and the website to support this podcast further. All right, bye guys. Thank you so much.